Good morning, good afternoon, or good evening. Wherever you are in the world, welcome and thank you for joining us. We are live at AutoSens Brussels 2023 from the Auto World Museum, surrounded by the history of the automobile while simultaneously embracing its future. We are thrilled to conduct our latest edition of AutoVision News live at AutoSens, where we talk with the leading minds in ADAS and autonomous vehicle technology development from inside the warm and nostalgic embrace of this incredible venue. Joining us now is Harry Chan, project engineer at WMG University of Warwick. Harry graduated with a master's degree in mechanical engineering in 2018 and then followed that up this year, graduating with a master's in smart, connected, and autonomous vehicles from the University of Warwick. Since graduating, he's been working in the autonomous vehicles field and working on projects that involve perception sensors, and he's currently working on the EU Road View project. Harry, welcome to AutoSens. Thank you for being with us. And tell us a little bit more about the EU Road View project and some of the work you're doing and some of the main objectives there.
Yeah. Thank you, Carl, and thank you for the AutoSens team as well for organizing this great event. I'm glad to be here and disseminating some of our work.
Indeed.
In terms of the Road View project, it's an EU Horizon project funded through the EU Horizon grant, actually. It started actually last year. It's going to be a 4-year project, so it's quite a long time.
Sure.
We have a large consortia of over 10 members spread across the EU and also with some of us at the UK as part of the consortia. In terms of the project overall, what we're trying to do is to understand how we can test and do robust sensing in adverse weather conditions. So where we have heavy snow, heavy fog, and heavy rain, for example.
Yes.
And as part of the project, we go through different stages where we have modeling for these adverse weather conditions. We'll have some partners looking at how to design filtering algorithms for these conditions, how to do control in all these conditions, say when we have snow or ice. Of course, it'll be quite slippery.
Yes.
So how do we do right control for that? Yes. And also there's a big group looking around how we can do testing in the loop, so X in the loop testing, which will use parts of all of what's created in the project for that.
Sure.
So it's a very exciting project that's on its way in its 4 years.
Yeah.
Thank you.
And extremely relevant, Harry, from all of us here on the AutoVision News team. We're from Michigan, from Detroit, and of course, Michigan notorious for snow, for rain.
Of course.
And so you're working on real world problems there with the EU Road View project.
Yes, of course. That's part of why Horizon was funded, actually, is to tackle all these challenging projects. Sure. As a collaboration between all the EU partners. Actually, particularly is headed by Halmstad University in Sweden. So, of course, Sweden, Nordic country, they have plenty of snow there. So there will be a final demo at the end of the project, which is actually looking to be at Lapland Proving Ground. Sure. All the way in Finland, North Finland. So yes, hopefully everything goes well and we'll have a successful end of the project demo there.
Absolutely. Harry, earlier I was reading through your bio, and you have experience when it comes to how noise affects output data. So specifically here, why is it important to analyze noise factors and then break them down to understand how that noise affects the output data? Can you take us through that?
Yeah. So of course, where autonomous vehicles are currently deployed, or where we have some autonomous vehicles deployed, especially in America, California.
Yes.
We of course know what the weather is like there. I would love to be there.
Yeah.
Right now, there is a lot of them are deployed in low noise environments or not as challenging conditions because that's what they can handle at the moment. Sure. If we want to roll out and ensure that way to roll out all these autonomous vehicles, we need to understand what are all the factors that can change or mutate your sensor data, your perception sensor data. If we think about the pipeline of autonomous or any autonomous system, you start from the perception around you, and then you take that understanding of the environment and you go through all your planning and control stages. Sure. So if we introduce noise at the first stage, all of it would then be affected. So that's why it's critical to understand noise in the perception stage. What we've done is that we try to use a framework, namely the P diagram, to actually go through the steps of understanding where are all the noises coming from, and what do they affect, because that can firstly give us a way to model them. Understanding how they're affected lets you do a modeling to say, I need to make sure this is affected in my model. Right. And also, if we have some recognition of what is affected, maybe that can feed through to perception algorithms to say, how do we mitigate against that? So this is a critical area of why we're publishing these.
That makes sense. That makes sense. Yesterday, as part of the preliminary day for AutoSens here in Brussels at the Auto World Museum, you were part of our tutorial sessions. Can you share what you talked that were involved in the program yesterday?
Yeah, of course, actually. Thank you for AutoSens for doing and hosting us for this tutorial session.
Indeed.
Actually, it also links back to what we just talked about. The whole tutorial session was around noise factors for these perception sensors. So what we've done in tutorial is we actually disseminated the framework, how we've used it and how we've applied it to, of course, the industry and academia and research bodies that were in attendance at the day. We've actually, essentially, as part of the tutorial, we've shown off what we've done as tables. We've got together everyone in their round tables to have a chat on what was there already, is there anything that they think is wrong or missing from there, so that we get that feedback back from industry that we can use to update and provide a better piece of work, essentially, and update the piece based on the understand. It was quite an interesting overall chat. I think there was quite a lot of interesting discussions that went. Companies especially were interested around camera, how does noise affect camera. They were interested in the environment side, which we're looking at in road view, and a lot of that, or even some companies that are not directly involved in the sensor side, but maybe like cleaning or how to place a sensor. They've also joined into this discussion, which was actually very interesting overall. So absolutely, lots of good feedback that we've had, and we're planning to wrap that work up in some form.
Good. We are speaking here with Harry Chan, project engineer at WMG, University of Warwick, an engineer, also a strong technical writer as well. Harry, you have some publications to your credit as well. Let's talk about those.
Thank you. Of course, with academia, a lot of our output on how we get our resource out is through academic writing or through journal papers and so on, through IEEE and so on, where they're peer reviewed to ensure the robustness of what we've done so far. Actually, some of the major pieces of work that I've been involved in was actually involving the workshop and the framework. So there were 2 publications out of that, which is the initial framework a few years back, or presenting the initial framework as part of our census letters. And that was around LiDAR. We've also recently did one actually published earlier last year, where we've also applied that to camera, and we've prepared a similar one to go for radar that should be coming through soon.
Awesome.
But in terms of overall work, I've also been working a bit around actually modeling noise factors. So right now we've actually recently got a paper accepted, and it's actually in early access phase on IEEE transactions on intelligent transport systems, where we looked at the effects of compression, using standard compression on camera data, and how it affects neural network performances. And that's an interesting piece of work that's actually available now on early access on IEEE. And of course, throughout our road view projects, we'll have plenty more publications coming through for the noise modeling.
Indeed, want to encourage all of our AutoVision News Live and AutoSense attendees, viewers and attendees to visit what IEEE, to learn more about Harry's writing, and to keep an eye on all the technical content from the University of Warwick. So Harry, so we've got the technical writing, we've got the engineering. What made you want to become an engineer in the first place?
That's a challenging question, I think. For me personally, as a kid, it's actually quite interesting to see how things work for me, especially back when I was a kid, where it's a lot less electronics, a lot more hardware related and so on. It's quite interesting when something breaks for me to just go and get my screwdriver and start taking things apart and say, is there something wrong here? Quite often I'll just take it apart and say, I've opened the front panel, I don't know what's happening, and close it again. But I think as we got the internet and so on, I would start taking apart and trying to understand from online what sort of things around. And it's just a field that's interesting overall because there's a lot of problem solving that we do on a day-to-day basis.
Right.
I mean, not even as just something mechanical, but the problem solving skills that we've learned from a mechanical engineering background is very useful overall. It's a way of thinking that is actually quite nice to have.
Of course. Your favorite car and why?
This is a challenging question. For me personally, I don't actually. I mean, looking around all these amazing cars we have at the moment here.
Yes.
But actually, as a mechanical engineer, I'm not as interested in car and car models, but more about how things work. And actually, in that sense, engine is a lot more interesting for me overall. I mean, I think one of the ones that I probably like a lot in terms of engines is Honda's VTEC engines.
Yeah.
They are amazing in terms of how they've engineered the fact that they have the mechanical linkage to do your valve timings. Oh, sorry, not valve timings, to do the timing at which the valve opens and shut and how wide they open for performance. Like that is interesting to me because it's very mechanical as well because they have a specific camshaft just to do that, whereas most of the car components now are all electronically controlled.
Right.
It appeals to me as a mechanical engineer to have something that is very solid in terms of having mechanical linkages overall. So that is probably one of my favorite piece of hardware within a car.
I like it. I think that every Honda enthusiast out there would agree with Harry on the VTEC. So you Civic fans out there, absolutely 100%. Harry Chan, project engineer at WMG, University of Warwick, talking about the EU Road View project, noise implications of autonomous vehicles in bad weather, so rain and fog. And then also, in addition to being an engineer, a strong technical writer, want to encourage all of our viewers to keep an eye out for Harry's latest publications. But Harry, in the meantime, thank you for being with us, sharing your expertise and thought leadership. Have a good rest of the show, safe travels back home, and let's maybe do this again sometime in the near future.
Thank you, Carl. It's been a pleasure.
Indeed. More to come as we continue with AutoVision News live at AutoSens Brussels 2023. From the Auto World Museum alongside Harry Chan, I'm Carl Anthony, AutoVision News.